there's so many nice perspectives about that that I'm sure we can have fun talking about. And I'll pass this off to Vanessa, who's here.
Hey everyone, I'm Vanessa. I think Dan didn't properly introduce himself, probably because he doesn't need an introduction, but he's pretty much the reason we're all here by making the first version of Smalltalk real and many others. So hi, and hi everyone else. I've been on Dan's radar, I guess, since 1996 or 7 on the Squeak mailing list. So quite a while. Later we worked together, and well, now we're friends. So I consider that a very big honor, and it's fun.
Noticed that Vanessa was really special from the beginning because all of the fun graphics hacks kept getting better, and new ones started showing up, and you've just taken it to the next level with Squeak.js too. That's really neat.
Yeah, and so both Craig and I are still on the Squeak board that's elected every year. And my day job right now isn't doing Smalltalk anymore, but I'm doing Croquet. So the new version of Croquet is in JavaScript. But on the side, I'm doing Smalltalk and writing a Squeak virtual machine in JavaScript, which is called Squeak.js. And I think that's what I'm going to talk about a little bit in my lightning talk today. So anyone else wants to talk for like 2 minutes about whatever they're up to, Smalltalk related? That would be fun. What's the time?
Dave?
Hi, I'm just working on. I'm kind of a competitor. I'm one of the principals of Pharo.js, which is building JavaScript on Pharo. But I also have just started working on a Smalltalk interpreter that is going to be. It's going to be just ASTs and executable code, and so I've just started working on this. The low-level stuff is going to be done in Rust. So
cool. Does that have any relation to Pharo.js, or is that separate?
Separate project.
Okay, cool. Anyone else?
I just want a quick comment to Dave, because he did doing Rust. I got a buddy that took like the original Xerox image and wrote the Smalltalk 80 VM according to spec in Rust, and it was really cool.
Nice.
It's the only VM I've actually read the entire source code to.
Cool.
That's neat.
And John, you had something to add?
Yeah, in terms of lightning talks, I'm not sure I actually can talk for less than 2 minutes on any topic, but I was inspired by the previous talks to go rummage around my local machine, and after the last session, we hung around for a while, not recorded, and sort of swapped tales. And a couple of things that I found on my very old machine, but has been moved with the drives forward for all these years, is we built this very small command line, or TTY Smalltalk we used to call it, and basically you can run a Smalltalk compile, hello world kind of thing. That image is about 900K plus a VM, and then the compiler itself is about 1.5 meg, and so that's kind of not that interesting. But I did find all of the packaging stuff, which allows you to take, recreate this and package it up as a standalone kind of deliverable in like less than a couple meg, and I did a little demo for it if we had time to show it. But as I said, 2 minutes is not quite enough time, but it was kind of cool, and it really brought me back like 20 plus years, because it demonstrates all sorts of features that we had that I kind of forgot. I knew we had them, but I just forgot. So we had read-only heaps that were ROMable for embedded systems. We had VM support for exceptions. When you write to as any processor would, if you write to a read-only store, you'd get an exception. If it's actually backed with RAM, you could map it read-write, just like the map today, and then you can continue writing to it, or you could do other things like show tracing. So there's a bunch of cool features that, as I kind of continued to look through this thing, I was finding. And so my feeling is I didn't quite have enough time to prepare a real talk, so if I offered it as a lightning talk, you'd have to convince me to do a real one later. The second thing, and the other multiple minutes of my 2 minutes of fame, would be I found the virtual machine builder that we used for building all of the Visual Age Smalltalks. And so that one has this really nice browser where you click on the implementation and it shows you the assembly code in x86, PowerPC, PA-RISC, 390, a mainframe, if you haven't heard of those. They've been around longer than, well, actually, not all of you, but some of you, and Spark as well, plus maybe a couple more processors. And you can see the code gen in real time, so you can actually modify the VM and see what's going on, and see what you're going to get if you try something. And so I was have that. But that's way more than 2 minutes for that kind of thing. Anyways, it just takes you back to the history and what we used to do when we were young and foolish.
Cool. We'd love to have you give a presentation about any or all of these things in the future.
Anyone else for a little lightning talk?
There's a little hand button in the lower left of this user interface. If you just anytime during all of this, if you have something to say, you can click that thing and we'll call on you.
Okay, I'll do mine. Is the screen being shared?
Yes.
Yep.
Okay, so this I did put the URL in the chat. This is just a little brain dump I did this weekend about a better JIT, a faster JIT compiler for Squeak.js. And the gist of it is the way to make any Smalltalk VM fast is to have a just-in-time compiler and avoid allocating a context for every cent, because that's the really expressive part of the Smalltalk semantics, but it's also really slow. And so other fast VMs go to great length to map contexts to a stack, because most processors are stack-oriented, and so having those instructions, machine instructions for managing the stack is what makes it fast. And then it provides some way to map those stack frames back to real contexts when needed. And in Squeak.js, I'm not targeting a CPU, I'm targeting another JIT compiler. Like all JavaScript VMs nowadays are JIT compilers, and they're pretty fast, pretty optimized, but you have to give them code that they can actually optimize. And turns out they cannot really optimize stack code. So my idea is to actually map the contexts not to a stack, but to variables, temporary variables inside of JavaScript functions. And then this brain dump here talks about how this could actually work. And there's a little bit of code, and this is what the current JIT produces, and this is an idea for the newest JIT. And at the very end, I do have some performance estimates just by hand coding that JIT, and those numbers are promising. Like from the current slowest 1.6 million cents per second in Chrome to 13 million seconds with the mockup, so that's almost a factor of 10 faster. That would be nice. And I would love if people read this and comment on it, say it's dumb, or it's there's a much better way to do it, or anything like that.
I can tell you now that's going to work, and it's going to work really well. What you're doing is we call it an operand stack, and basically you simulate the stack by allocating temps, arbitrary number of temps, and the underlying optimizer will then take care of optimizing them. And the only time you get in trouble is if you have to recreate your stack and you have a whole whack of temps. You end up pushing them into some real stack. But for most JIT compilers, if you have a fairly large bulk of code, all the pushes and pops just go away and they turn into temps. Exactly. And in your case, you're generating for code for a garbage collected language already, so you don't have to worry about keeping track because someone's doing it for you. If you do this in underlying code generators, you have to keep track of where the stuff is. If
so
they
the one complication with JavaScript is that from the outside you cannot peek into a function activation, so you don't have access to the stack of any function. So what this does here is provide a little thing that lets you peek into the stack if you need to, and creating this thing is actually slow. So there is, I mean, still a win overall. But it's slow. So if you can find something that's better than that, I'm
so are you using that to peek in when you had to create contexts or not, or is it when you?
Yes. So this is really just it's a closure that's inside of each function activation, and I pass that closure into each call that I do. So if I need to reify a context here, or I need to access the sender, I can just do that. And it works, but doing all that on the way down is expensive, especially if you don't need it. So I have another one which is exception-based, which is this one here, which is twice as fast. But so this one only accesses those variables on unwind. Like when you throw an exception and it goes back up the stack, then at that point it captures all the variables. However, unwind or exceptions in JavaScript are destructive. Like not like in Smalltalk where you can just throw an exception and continue going, right? In JavaScript, throwing the exception necessarily unwinds the whole stack, and that's not nice. So yeah, I don't know yet which one will be faster. Okay, so I'm grateful about any feedback on Twitter, on by email, or there's an issue linked on GitHub. So any of that. And I think now we're getting ready for the main event. Hernán, Dan, did you want to announce that, or how?
Yeah, well, let's see. I'm just really happy that Hernán's going to be talking about this. And, types in the world of Smalltalk is a delightfully controversial topic. And there's no doubt that it's always nice to know more about what your program is and does. And it in times like when I've thought about this stuff, type isn't the only thing you can do. If you have a hold of what's going on, you can also measure, the different values that variables range over. So it's a wonderful foray he's made into instrumentation, and I really look forward to seeing how he's been able to take advantage of that in the user interface and the programming support. So take it away, Hernán.
Okay. Thank you very much, Dan, and thank you for letting me show what I call live typing. I didn't take the live from your lively kernel, Dan. So
it's plenty of live to go around.
But I like the name, so I think it influenced me a little bit. So okay, I'm gonna start with the presentation and of course give a live demo. And feel free to stop me and ask questions. I think we have plenty of time to talk about it. So yeah, those of you that don't know me, I'm one of the founders of a company in Argentina called Tempines. I'm in Buenos Aires, Argentina. Also one of the founders of the Argentinian Smalltalk Foundation. We had the opportunity to bring Dan here in 2009 for the conference, and it was great. And I also a professor at the computer science department at the University of Buenos Aires. But really, if you ask me what I like or what I do is, to program. I'm a passionate programmer. So type information in dynamically typed languages has always been a topic of research. It's like Dan said, he was really interested, as we will see, a long time ago about this. This is not a new thing. We can say that there are mainly two ways to have type information in those languages. One of them is type inference, and the other one is, you manually go and annotate the types, basically very similar to what statically typed languages do, but not as, strict, we could say, as statically typed languages. And generally, those ideas are combined with type inference. And as I said, this is not a new idea. Type inference for dynamically typed languages have been, studied for a long time. You can see here two papers that maybe they are not the first one, but that are related to type inference. The one in 1980 and the other one in 1981 about inferring types in Smalltalk. Then it's really interesting what it says in the conclusion. And I'm going to read it. It says that, Al Perley suggested that if you run the system against some examples and record all the types of arguments and the results, you will probably get, to the same, covers quite quickly, and get and obtain those, the type information very close to what you can do with type inference. And it's also interesting to see that this idea that Suzuki is mentioning, it was also mentioned by Mitchell. And, I looked for that thesis. I couldn't find it, but it is interesting is that it is an idea from 1970. So just to mention a little bit, how what I'm going to show is not really new. It's older than Smalltalk. But anyway, type inference is a way to get type information on dynamically typed languages, but it has some disadvantages. We all know about them. Sometimes it's slow, or the information is not complete. Sometimes you get invalid information. It's not that easy, and we know that because if it was a great solution, all dynamically typed languages would use it, and they don't. As I mentioned, and as Dan said, we can see here another paper from 1982, written by Dan and Borning, about type declaration or annotating types. That's the name that we use, the current right now, and combining that with inference. And of course, we all know Gilad Bracha implementation of Strongtalk that used type annotations. It was, I think, the most interesting implementation in Smalltalk about, regarding those things. And right now we're starting to see more and more about this type annotation stuff in mainstream languages, like in JavaScript. Now we have TypeScript that you can add, types in the code, or Python, or you can also add types, or Ruby, and so on. So we have all these, mainstream dynamically typed languages that are using type annotation to get more information and help the programmer. So what I want to do now is to show the, how in Python this is being used, okay? The state of the art in Python. I know that this is a Smalltalk, webinar or whatever, but I wanted to show you to see how other languages are, and then compare to what I'm going to show. So here I have a very simple example: class A, class B, class C, and message foo implemented in class A and B, and a message send of foo in this method bar. Of course, if I want to rename, I can go and rename foo with foo1, let's say. Let's do the refactoring. It will rename the method foo in class A, but for some reason it doesn't do it in class B, and it doesn't show me that I could do it. And of course, it renames the message send. So, well, I didn't show that if I can run this and it's running, it's not generating any issue, but if I rename it, let's do it again. If I run this code again, it fails. This is very common. It's a very common mistake that we have, a common error that we have when we're doing rename and refactorings in dynamically typed languages, because we don't know exactly which messages have to be renamed, our message sends. So if we add type information here in the parameter x, and we say that it's of type B, now if I rename, before doing that, let me show other thing. If I want to rename foo from here, it won't allow me to do it, because for some reason it doesn't. And the reason is it doesn't have type information to do it. So if I say that x is of type B, you will see that if I rename, now it allows me to rename the message here. And if I rename it, let's say foo1, it will rename, of course, the implementation of foo in class B and the message send, and everything will work correctly. So, type information in this case allows you to do a rename safely. Same thing for an inline. If I want to inline, let's say M1, it will just inline it here when I was sending, let me show you the example again, sending the message M1 to self, but it won't inline it here because, again, it doesn't know the type of X. If I add the type to X and say, okay, X is of type A, and now if I inline this method, well, it will inline it in M2, it will inline it in the method M2 in class B, and of course, it removes it from class A. So these are the kind of things that you can improve when using type information in dynamically typed languages, and of course in statically typed languages. But what are the disadvantages that annotating types have? Well, first of all, you have to change the syntax of the language. And that makes the code harder to read because we are not used to see types in our code. And of course, the programmer is the one that has to annotate the types and to maintain those annotations. That is something that we don't usually have in mind when writing types in our code. The other thing is that usually those solutions, because are based on textual languages, concentrate on type checking. From the language point of view, the only thing that they care about is type checking, and all the improvements of the tools are, part of the IDEs. Each IDE will do or not special things with that information. In this case, I show you in Python, PyCharm, the IDE PyCharm, where they use type information to improve the factors. So that's the state of the art, we could say. What is LiveTyping? Well, it's a new way to have type information. And of course, it's not new. It's as old as we saw at the beginning. But the idea is to automatically collect the types when the system is running. It's not the programmer that has to annotate types. It's not inference. It's automatic type collection of types. So the idea is that you have the VM that collects the types every time you assign an object to a variable, you send a message, and so on. And then we take that information and improve the tools using that information. So, well, as I said, it's not a new idea. It's for sure, a lot of people, a lot of us had this idea someday, but it's an implementation that is working. Of course, it needs a lot of improvement, but I will show you how it works. One interesting, one thing that I like to mention is that the goal of live typing is not type checking. You can do type checking, as I will show you, but for me, the main goal is to improve the tools like refactorings, auto-completion, looking for senders or implementers and those kind of things. I think that's the most important thing, at least from a Smalltalker point of view. Type checking, yeah, okay, but it's not the main thing. So, any questions? Are we okay now? Yeah. Okay. How's the implementation? Well, first of all, let me see. Yeah, this is the right one. Let me show you first how I collect the type information for instance variables. What I did is to add a new instance variable to class description called instance variable raw types. That's an array of arrays, as I will show you right now. Let's look, for example, for the class simple measure. The class simple measure has two instance variables, amount and unit. This class, instances of this class are measures like 1 meter, 10 minutes, or whatever. If we inspect simple measure, we will see that we have this instance variable raw types, instance variable, and that is an array of two elements that are arrays. And how they relate to instance variable? Well, the first array is where we collect the types of the first instance variable. So here we have the types that were collected for the amount instance variable. And here we have the type that were collected for the unit instance variable. So each class has this array of arrays where type of instance variables are stored by the VM. Why are they arrays of arrays? Is because that's very easy to use from the VM point of view. So let me initialize that information here. I will show how the information is set. So now we can see that simple measure does not have any type for amount and for unit. But if I create a measure, like say, I don't know, 1 meter, that's the way to do it here. We can see that now on the array of amount, it says small integer because we assign 1 to that instance variable. And for the array of the units, we can see that it says base unit because that's the class of meter. If instead of 1 meter, I say 1, I don't know, kilometer, we will see that this, proportional derived unit was added as a type for the unit instance variable. Also, if I say, I don't know, 1 divided by 1, I don't know, 10.5 kilometers, now we see small float 64, and so on. Every time we, create new instances of simple measure, it will add those types to instance variable row types. So that's how types are stored in the image. How does the VM work? It's very simple, as you can imagine. Every time an object is assigned to an instance variable, we get the class of the receiver, and then we look for that array of arrays for the instance variable row types. And then if that object is an array, and if the index of the instance variable that we are storing that object to is less than the size of that array, just to be sure not to break anything, we get the types related to that instance variable, and then we send this message that is the one that do all the stuff, all the cool stuff. Well, first of all, it checks that the array is not nil, because we could here, we could put nil here, and that will not collect types for the unit instance variable. So that's a way to avoid collecting types, for example. If it is not nil, we take the class of the assigned object, and then we look for a space in that types array. And it's very simple. We take the first element of the array, and we see if it is of the same as the type that we want to store. And if it is the same, we just return. And if it is nil, in that index in the array we have nil, that means that we can add this new type to the array, so we do it. And if it's not nil, we go to the next element of the array. So that's the way the VM stores, the types of each variable in this array. The size of the array is configurable. By default, it's 10, because we have 10 fingers, and it works pretty well. So instance variable row types can be nil. For example, if you don't want to collect types for a specific class, for the instance variable of a specific class, you put nil in instance variable row types, and also the types array of a specific instance variable can be nil if you don't want that specific instance variable not to collect type. And of course, you can make it smaller or bigger, the size of that array. How does it work for methods? Arguments and return types and so on. So in this case, what I changed was the additional method state, and I added to it a very similar structure, variables row types, that's where parameters and temporary types are stored, return row types, that's the types for the return of that method, and then we have other stuff related to variables that are shared by a closure and are temporary in a method. I don't want to get into that detail, it's not necessary. But let's go again to simple measure. Let's see a method like divide simple measure. Let's inspect this method. Here we have the additional method state, and we can see in this case there is no type assigned to parameters or temporaries and the row types, and that's because I removed them before in the presentation. So if I come here and I say, okay, I want to divide 10 meters by, I don't know, 2 meters, we can see that, well, here it says simple measure, simple measure, simple measure was not an interesting example. But if we look at the code, a measure was assigned with a simple measure object. numerator is also a simple measure and denominator was a simple measure. If we do something different, for example, I don't know, 10 divided by 2 meters, we will now see that the measure was a small integer, the numerator was a small integer, and so on. And we can also see the return types. In this case, it was a small integer. In the first case, in the second example, it was a simple measure. So every time a method gets activated, what I do in the VM is I look for all the parameters in the method frame, and I keep the type information for the parameters. The same thing every time an object is assigned to a temporary variable. Everything ends, sending the message to keep type information, blah, 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 blah. And the same thing for return. So that's basically how it works. It's very simple, it's very fast. And I'll show you some, I'll show you how, performance hit, but it's around 40%. It's not terrible. So I don't know if there are any questions so far, or if you are okay. No questions? Cool. That means that everybody understand or nobody understand.
Did you say 4? Did you say 4 or 40%? Sorry.
40.
40. Okay.
Yeah, 40%.
Dave Lewis?
I was just going to ask, the VM support seems fairly simple. Is that something that ought to be included in our available VMs? I should probably answer this, but it's simple.
Yeah. It's the changes in the VM is very simple. I'm not a VM guy, and I could do it because the VM, the Open Smalltalk VM, is written in Smalltalk, and the change that I made is in the stack VM. It's not in the JIT VM. So the VM I'm using right now is the stack VM with these changes, and yeah, it's pretty simple. There are like 10 methods, no more than that. No more than that.
I'm going to barge in and say, you say you're not a VM guy. And when we did Squeak, I have hacked assembly code and microcode and all that stuff. But it was clear to me that, if we could bring it all up to the level where everything was in one language, then somebody who was a serious Smalltalker could actually do something serious in the VM. And here you are, you're doing it. That's great.
Yeah. Thank you. You had a great idea. You had a great idea, and because of that, I can understand how the VM works, and I show that to my students. Because it's simple. It's a Smalltalk. It's not a complex language. So yeah, that was great. It is great.
Great job.
Yoshiki?
Oh, hi. So, do you have any plans to support collections?
Yeah. I'll show you that at the end. Yeah. Not only collection, but generics in general. Or templates, how they call it in C++.
Yeah.
Parameterized types. Yeah.
Right. Do you have a plan?
Yeah, there are 2 guys working on their thesis right now, adding, collection support, and they have a very interesting idea. It's working. I'll show it at the end. Yeah.
Mike Klein. Oh, sorry.
Yes. No. I was going to say that it's not production ready, but it's a starting point. It's really good. Yeah.
Mike Klein.
Hey, I apologize if this comes off snarky because I really don't mean it that way.
Okay.
But so I'm always a little, when people talk about like dynamically typed, I kind of sometimes think to like what the strongly statically typed languages like in the Haskell ML family, that have an actual type theory to them. And when I mean, all this stuff is really cool, but when I hear about it, I think it's more like class inferencing, particularly in the context of the V8 runtime. And I think it's cool and useful, but I always wonder if there, you can have some kind of actual type theory applied to it, and then I wonder how well that'll work in a dynamically changing environment like Smalltalk.
Yeah, I completely agree with you. When I say types, I'm talking about classes. I agree, but as you will see, you can get the idea of type when you're combining different classes. And yes, of course, there is a theory behind all these ideas that you can see in other languages. Like, I showed Python, and there is a theory behind how to use, types in a dynamically typed language like Python and those things. So it's the same idea. Of course, that what is different is what I mentioned at the beginning. The type checking or the soundness of the type system. But as you will see, that's I'm going to show right now, the improvement in the tools is so great that, if you're used to work in Smalltalk, in a dynamically typed language, just having that information will be, a boost. It will be great. So, I'm not trying with LiveTyping to replace or to make Smalltalk work like a statically typed language. That's not the idea. If you like statically typed languages, just go and use a statically typed language.
Well, let's just say I'm still in the love-hate affair period with statically typed languages. But sometimes I'm writing Smalltalk code that really feels like it could be statically typed, and I kind of wonder whether this as a system could help me morph my code into it actually being translatable to an actual static type.
Well, it's possible, but I like the dynamically type idea behind Smalltalk and the ability to change code on the fly. I always write code in the debugger. It's almost impossible to do that in a statically typed language. Of course, each type of language has its advantages and disadvantages. I prefer the Smalltalk advantages.
Well, me too. That's why I'm here. I'm certainly not. I don't have any hate on Smalltalk, but having tried to trying to do more and more Haskell, it's definitely a love-hate thing. But it's not. There is an attractiveness to it, I guess.
Of course. I agree, and we don't have to. There is a lot to learn from Haskell. There's a lot to learn from other languages, and take those ideas to Smalltalk. That's what I did. I will show now the tools, how they work. And I took all those ideas of working with Java and using Eclipse, So it's like bringing those tools and, how those tools work in other languages. So, I agree with you. Yeah.
Oh, well, speak not of the language whose name shall not be spoken.
Okay. So is another question, or should I continue? Okay, cool, great. Okay, so now let's see the interesting part. I think the implementation is okay, it's good, but let me show you a little bit. I'm going to base all the examples on a tic-tac-toe implementation I have here. That is very simple. We have the tic-tac-toe class that knows the positions of O's and X, and it uses a state that implements the state pattern. And here we have the hierarchy of the state that can be, that the game is tied, or O1 or X1, or O is playing or X is playing, and so on. And here we have the test of the 26 test. So okay, that's what I'm going to use as main example. And let's start with, how can you see the types that are collected? So if you go with the mouse and you put the mouse over a variable, you will see the types of that variable. In this case, the types that, the class of the objects assigned to states were playing X, playing O, player X1, blah, 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 and all of them have tic-tac-toe state as superclass. If I put the mouse over here, it says, well, player O positions is an order collection, player X position is an order collection, and I can also, if I press in this case Command-Shift-P, I can also get this, like a menu that shows you all the classes and the super type, and you can browse one class from here, and you can also play adding or removing types from here. For example, I can say, okay, let's add small integer as type. So now if I come here, it will say, okay, the types that were assigned to state are, well, let me show you like this, game type, blah, 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 and small integer, and they don't have a common super type, but object. So if I come here, I will see all the selectors that all those objects have in common. Of course, you can also remove types. I'm going to remove this. And this works not only for instance variables, but also for parameters, like here, a position, its point. You can see the return type of a message, of a method. If I put the mouse over here, it's tic-tac-toe. Between and returns a Boolean that is true or false. The at returns a point, and so on. You can, put see the types like that everywhere, and it's very useful. And I like the idea of not writing the types in the source code. At the beginning, I did that. Like annotated types. You could come here and select, I want to see the source code with types. But I think Javier Pimaz, I think is here. He gave me this idea of showing it as a balloon help. And I think it's more useful because you don't mix types with the code that you write. So that's a very useful tool. And it's really useful when you are looking at code that you didn't write. For example, let's see, add alarm, morph. When you have messages like this one, where a name of a parameter is arg1. What does it mean, arg1? So here we can see that arg1 is a widget morph, okay? Or for example, delay time. Okay, what is delay time? Is an integer, is a duration, is a measure. So you cannot see that, you cannot know it just looking at the code. So, but now if you come here, at least you can see that it's a small integer. Okay, it's not a duration, it's not a measure, it's a small integer. And the same thing here. Args, you see that it's an array, and so on. So having this information is very useful for code that you didn't write. And the nice thing about Smalltalk that we all know is that it's running all the time. So this information is collected automatically. We don't have to do anything. Of course, there are places where, like here, there is no type information for this parameter because this method has never been executed in this image. Okay? But, if you have a good coverage with tests or those kind of things, you will get a very, very nice type information and complete. Well, what about auto-completion? That's another tool that gets a lot of information for when you have this kind of type information. Let me reset the types first. I'm going to remove the type of this class. So now var1 has no type information. You can see here. So if I, ask for the auto-completion, it will show me, the common messages that you can send that you can send that based on, I don't know what, and if you start writing all the messages that start with A or all the messages that start with B and so on. As you can notice, there are some of the messages that are in blue and some of the messages that are in black. What's the difference? The difference is that when a message is in black, that's a message that the object will answer for sure. When the message is in blue, the system cannot tell you if that message is going to be answered by the receiver. And what's the reason here? Well, we don't have the type of var1, so all the messages implemented in an object are going to be answered by the object that is referenced by var1, but I cannot say anything about messages not implemented in object like and or if else that are implemented in the Boolean hierarchy. Okay, so let's run the test, and now we can see that var1 is of type string. So now, if I ask for the auto-completion, I will see the messages that are implemented in string and its superclasses. An interesting thing is that now that we know the type of the variable, we know the class, we can help the user with the information of the message that we are showing in the auto-completion. And so we can see here that, I don't know, find string is, it's waiting for a string and it returns a small integer and so on. I don't know, find selector, returns a symbol, and those kind of things. So it's very useful when you are learning Smalltalk, because you can see, part of the documentation of the messages that you want to send here or in the auto-complete. So how does this work when you have a variable that pointed to objects that are not part of the same hierarchy? Of course, that all classes subclass object, but let's say var1 was assigned with a date and with a small integer. So it's not really a common supertype. So here, if I ask for the auto-completion, it will show me in black the messages that are implemented in both classes. And here I can see that class is implemented in timestamp and in small integer, same with minus and so on. But if I go a little bit down, you can see here that times is not implemented in a date hierarchy, it's only implemented in small integer, and the same with other messages. So, it shows you which messages are going to be answered for sure and which messages may not be answered. And okay, this is how the auto-completion works. There is a very interesting concept that I call dynamic type, and again, it's not something that I created. I took the idea from some papers that I read and questions that people ask me. But an interesting thing about having type is, for example, what's the type, the return type of the message yourself? Because the return type of yourself depends on the receiver. If the receiver is a small integer, yourself returns something of type small integer. If the receiver is a date, so the return type of yourself should be date. So to be able to do that, I created this concept of dynamic types that depends on the context. So here, yourself, if I ask the return type of yourself, it will tell me that it's example because the receiver of the message is self and self is examples. But if I don't know, write one yourself, now it will tell me that the return type of yourself is a small integer because the receiver is one. So if we look at the implementation of yourself, and I want to know the return type of this message, it will tell me self. Self is a dynamic type that, automatically gives you the type of the receiver. Same thing happens with class. Now, if I want to know the class, class is implemented in object, and the return type of class is the dynamic type class that returns the right type based on the receiver of the message. So in this case, yourself returns example, returns unexamples. So class is examples class. And the cool thing about this is now, if I ask for the auto-completion, I will get the instance creation messages of examples and not of another class, because the return type of class is example class. If I have, for example, let's say, I don't know, I'm not sure this is going to work. See yourself here. What is? Yeah, this is not going to work. But yeah, anyway, let me see if I can. Yeah, let's see. I have something like this class. This is an array class. So now, if I ask for the auto completion, I will see the instance creation messages of array. And the same thing for new. New has the type is instance. If we look for the implementers, well, there are too many implementers. Let's look for the actual implementers, in this case, only behavior. If we look at the return type is instance, and again, that means that it will return as type the instance of the class of the receiver. So new returns an instance of examples because the receiver is an example class. So that's a very interesting feature, and it's very important for the auto completion and all the other tools that we have to work correctly with these messages that are really polymorphic, we could say. Okay. Actual implementers. What is this? So let's go again to tic-tac-toe, and let's see the message mark with X add. I don't know if the message is understandable, but it means that you are marking the tic-tac-toe with an X at this position. And if we look for implementers of mark with X add, we'll see that we have 5 implementers. One of them, of course, is the one in tic-tac-toe. But the other 4 are in the tic-tac-toe state hierarchy. Yes, these other 4. But, that's a problem because tic-tac-toe and tic-tac-toe state are not in the same hierarchy, and I may or may not want to keep them polymorphic. That depends on how you think your model. So what I can do is I can look for, in this case, I have the cursor over here, so I will look for actual implementers. So what it will do, it will take the type of the object of the class that I'm looking at right now, and it will look for the implementers. No, sorry, it will, in this case, oh, I'm confused. I don't remember how it works for this. Well, don't worry. Let's come here. Mark with X add, that is being sent to state, and we know that state, the type is, the tic-tac-toe state hierarchy. So if I look for actual implementers, it will show me only the 4 implementers of that message in that hierarchy, and it will not show me the one in tic-tac-toe. If I look for actual implementer here, it will show me only the tic-tac-toe implementer. And there is also what I call actual local implementers. there's a small difference between actual implementers and local implementers. And for example, let me see. If we look for actual implementers, let me remove the game over state type from the instance variable state. Game over. Okay. Let me remove player 01. Oh, sorry. Remove type. Okay. So if I look for actual implementers, it will show me the 4 actual implementers. But if I look for the local actual implementers, it will only show me the 3 implementers of the real types that were assigned to state. Okay, so actual implementers will look for this common superclass and then look for all the implementers in that hierarchy. Local implementers will only show you the implementers of the types that were of the objects that were assigned to that instance variable. Okay, so that's what actual implementer is. It shows you only the implementation of the message that you're looking for in the types of the object that you are looking at, of the type that you're looking at. Let me see here if I have, for example, here, game if of type tic-tac-toe, and again, if I look for actual implementers, it will only show me the implementation of that message in tic-tac-toe. And the same thing with actual senders. It looks for the senders based on the type information of the variable. So let's go again to mark with X. Where is it here? So if I look for common senders of mark with X add, it will show me 7 senders. Some of them are sent to instances of tic-tac-toe, like here. Some of them are sent to instances of the tic-tac-toe state hierarchy, like here, or the tic-tac-toe itself, like here, and so on. Yes, you have all the senders. What does actual senders do? Well, it takes the type of the receiver and only looks for the senders of the messages that were sent to instances of that type. So if I look for actual senders of mark X with X add of tic-tac-toe, it will show me, well, in this case, 7 again, because, here, and all the ones that are sent to tic-tac-toe, but look at this. This is when you can start seeing the difference. It's also showing me that mark with X add is being sent by the message mark with X add, but only highlights this message send and not this one, because we are looking for actual senders, implementers of mark with X add implemented in tic-tac-toe, and this message mark with this message send is not being sent to instances of tic-tac-toe. If I now look for actual senders of mark with X add from here, it will only show me one method, and it will only highlight the sender sent to instances of the hierarchy of tic-tac-toe. It will not highlight this message send because it's being sent to instances of tic-tac-toe. So what we have here is the ability to separate, what sometimes we call fake polymorphism, and look for the real senders and implementers. You don't have to, how do you say this? You don't have to filter yourself these messages anymore. So if we go, for example, to build stream, look for reset. No, it's not here. Where is it? Positional stream reset. So if I look for senders of reset, we will see 29 senders. It's very difficult to know if are sent to instances of positional stream or with subclasses. But if we look for actual senders, well, you can see that are much less. And also there is, all these senders here are for sure being sent to instances of positional stream and its subtypes. And here we have a new notion of what I call possible senders that are, senders of that message, but that I cannot say if they're being sent to instances of that class or not, because in this case, we don't have type information for this variable. Or here, I don't have type information for this parameter and so on. So I'm not sure, but you can, if these are real senders, but at least you can see it as possible senders. So now that we have actual senders and actual implementers, the refactorings, work a little bit different. Again, if we try to rename, let's say I want to rename, let's go again to the same message, mark with X add. If I want to rename this message, let's say mark with X add 1. Oh, what's going on? Here it's asking me for the scope of, to look for the senders and implementers. Let's say I select, look for all the senders and implementers in the whole system. So it will show me, okay, these are all the implementers that are going to be renamed, and these are all the senders that are going to be renamed. So I have to, for example, if I only want to rename tic-tac-toe, mark with X add of tic-tac-toe, I have to manually remove this one and this one and this one and this. And then I have to go to the senders and say, okay, I want to remove which one. Okay. You have to manually filter the senders and implementers. But if instead of doing, the normal rename, you do a rename, but using actual scope, it will look for the actual implementers of that message. In this case, is 1, tic-tac-toe, and for the actual senders of that message. And here comes the interesting part. As we saw before, this message send is not being sent to a tic-tac-toe, but to instances of the tic-tac-toe state hierarchy. So here it's showing me that it will rename only this message send, but not this one. And that's because no implementer of mark with X add of the tic-tac-toe state hierarchy is going to be renamed. So if I say just refactor, we can see that it renamed the name of this message send, but not this one. And we can see that the message is the same in the tic-tac-toe state hierarchy, and the senders of this message were all renamed too. So that's a very powerful tool. Now you can rest on this type information to, filter the scope of the senders and implementers. And, if you have tests and if you were doing TDD or whatever, the types are always pretty complete. So you can be pretty sure that you are not going to have problems. So rename that to the same name as before. Okay, what else? Of something I forgot to mention. These kind of refactorings, the looking for actual senders and actual implementers is used in all the refactorings that we have. For example, I don't know, add parameter, remove parameter, those kind of things. All these refactorings, you can look for actual senders and implementers, not just the rename. I have also a guy working in his thesis about adding new refactorings like inline that are going to use that type information also. Okay, now it's time for the type checker.
Hernan, let me just interrupt and say we should plan to wind down fairly soon, just so the people who allocated an hour will be able to leave.
Oh, okay. Yes, no problem.
You're doing great.
Okay, yes, thank you. Just to finish, you can type check your code. For example, here we have ID1 is of type small integer, and I don't know if you saw it, but here it says can be nil. This is because I know for sure that nil was assigned to this variable. So if I type check this, it will tell me, okay, date is not implemented in a small integer or an undefined object, so I can change that. And now it says, it removed the error because print string is implemented in object. And here it says factorial is not implemented in undefined object. So what can I do is ID1 is not nil, ID1 factorial, and no more errors. And if you implement a type checker in a dynamically typed language, you have to do things like here, for example, let me see here, to be sure that when you are type checking your code, like this one, if ID3 is not nil, so ID3 could be nil or small integer. So that's weird. This is this. Oh, sorry. If nil, if it is nil, yes, subclasses is implemented in undefined object. So that's the reason this is not doesn't have type errors, even though ID3 could be a small integer. But you're checking here that if it is nil, execute this. And the same thing for if nil is nil or and those kind of things. And of course, if you're looking, is kind of or has model, those kind of things. The type checker supports all these kind of dynamic type checkings that we usually have in dynamically typed languages. Okay, so just a little bit go faster. How much time do I have? Done?
Oh, it's been about an hour, and I can stay around until the top of the hour for discussion. But yeah, wrapping up fairly soon would be good. Yeah.
Okay. So just yes, 5 minutes and behavior.
That'd be great.
Yeah. So if I type check behavior, we can see, for example, this is a interesting error. It says subclasses do is not implemented in behavior. And it's, in all subclasses, a message implemented in behavior is sending the message subclasses do to self. Of course, behavior has no instances, but if we look for implementers, we can see that it is not implemented in behavior. And I think it should be implemented as subclass responsibility or something like that. And if we do that, this message will go away, this error. Okay, so let's move quickly. Some statistics. Performance, as I said at the beginning, is almost 1.4 slower. And remember that the implementation I have in the VM is in the stack VM, not in the zip VM. But as you could see, you don't see the difference. When you are programming, there is no difference really, because the VM is, laughing when we are programming. About memory, with the default implementation, with the type arrays of 10 elements for each instance variable, each parameter, and so on, it's almost 50% more of the space that it needs. But as you can see, with the machines that we have right now and the memory that we have, is massive. It's peanuts. Conclusion, well, as we could see with Arc4, we could have type information and get rid of most of the disadvantages we have with dynamic type languages. You as programmer do not have to maintain the types. Anyway, so it's very simple. It improves the programming experience a lot. Doesn't change the syntax. It doesn't stop you from compiling. You don't have to use it if you don't want it, and if types are not in the source code. So I think this solution, I humbly believe that it respects none of Smalltalk spirit, but that's something I believe, and I like to believe. And I would like someday to start saying that Smalltalk is not dynamically typed but lively type. I hope I hope we'll see that someday. Future work. Right now, we are not collecting types in closure parameters and variables. There is Ines Sosa is working on that, also for her thesis. Let me show you quickly how we can show the types in for collections. Well, we have this class type array collection. It's an ordered collection that collects types. I'm not going to get into the details of the implementation, but as we can see, we added 1 to that collection. So if we see the types, we see that it's a type array of a small integer, and the return type of add is a small integer. First, the return type is a small integer, and so on. And if we have another example here that adds 1 and hello, so now the types of this type array collection of a small integer or a string, and of course, first returns small integer or a string, and of course, the auto-completion and everything works as expected. And of course, you can have arrays of arrays. So here we have an array that contains arrays. So here we have a type array of type arrays with numbers that are fractions or small integers. That's something that Ana Felizati and Mariana Sousa are working on, and they're finishing their thesis and really happy about it. And well, there are more refactorings coming on. A lot of ideas. When you start using this, you start having a lot of ideas and ideas and ideas. So here they are, and for sure there are more. And you can download it from here. And questions.
Great talk, Herman.
Yeah.
Thanks, Hernán. Thank you.
Thank you.
Yeah,
I hope you like it. Thank you.
Very cool.
I'm happy. Not with the talk. I'm happy with live. With LiveTyping.
Yeah, good.
We can't ask for features because I have a bunch of feature requests.
Yeah, of course. If you can pay for it.
I'll get my checkbook out, but let me see if you have them first.
Okay.
Do you have any plans around things like sharing the type information across multiple users so you get persistence? Because when I share code with someone, I wouldn't mind shipping them the type information that I gathered while I was testing it, so they don't have to run a bunch of code to get some of the benefits. Those kinds of things. Like
I haven't
sourcing of the type information.
Yeah, I haven't done anything special for that, but it's pretty easy, and it's useful also if, for example, you have a legacy system, you don't have tests, but you have the system running, so you can run the system with the the LiveTyping VM, collect the types from production, and then put them on development. So yeah, I haven't done anything special, but those are objects, so it's just a matter of saving that to a file and read it from the other image.
The parallel question or the corollary would be, do you have ideas around, could I get alerts when I see the first time I see a type that I've never seen before? So for example, if I'm using it wrong or those kinds of things. And then in addition to that, What's your thoughts on cleaning up the type pollution after I debug something and I passed in all sorts of junk that shouldn't work, and now you think they're valid types because you just kept track of what I tried?
Yeah, that's a really good question. Really good question. Right now, what I do is every time you change the shape of a class, I remove the types for the instance variable of that class, and every time you change a method, it removes the types, of that method. That's the way, the easiest way to maintain this cache of types. But yeah, I thought about other things. For example, if the type is I don't know, a mock or something like that, the class is a mock, so it's very easy to remove that from the list of classes. And also, I thought about the idea of like freezing. You could say, I want to freeze the types of all the parameters of this message, for example, and that's pretty easy to do. Just short the size of the array, the types array, and then no other type will be collected for that instance variable. So you can do those things, but yeah. Sometimes you will have to manually invalidate the cache or something like that. That's something that has to be. There's more to think about it. Yeah.
Yep. Okay. Thanks.
Yoshiki?
Hi again. So it's interesting to see that actually your code style is affected by types. You wouldn't create those end state, tic-tac-toe end game state, and you wouldn't make those measurement, many different types of measurement stuff. But yeah, if you know that helps, you would create them. So I think the coding style is indeed affected by the type system. So I want to hear what you think about that.
Well, not really. What I showed about the measures is something I wrote in 2003, 2004, before all this. And the tic-tac-toe example, I wrote it also before having LiveTyping. I don't, in the everyday work I do with Smalltalk, I didn't change my way of working or programming because of LiveTyping, and I didn't change the design of what I write because of that. It helps a lot when you have to refactor, when you have to look for senders and implementers, but it didn't affect the way I design, at least to me. I don't know if I answered your question.
No, yeah. Okay.
Okay.
Yeah, just a quick one. Once you have run your image on that VM where collected the type information, then that image you can move to other VMs too, right? And still have it. And as long as you don't delete that.
That's right.
It's
I can the same image. I can use it in common VM because it doesn't remove anything from the the meta model, but it adds only that instance variable in class description, and for the VM that doesn't exist for the normal VM. So yeah, you can use the same image in a JVM normal VM. Yeah, no problem.
Cool.
And that was one of the goals I looked for when I thought about the design for that. Yeah.
Hernán,
yes.
Since we're in question time, could you elaborate on the handling of type collections? What is happening?
It's okay. That's very difficult. you know that. Okay. It's very difficult because you have to merge information from different instances, because now what's the difference between collecting types from a variable or collecting type for a collection. The difference is that how can I explain that? When you have collections, you have to keep the type information for each collection. And when you want to see the type information for the variable, you have to merge the type information of all those instances of the collection to show that in the variable. I'm not sure if I'm explaining myself correctly, but that's the biggest issue. And the issue also is that you can have a collection that is the same collection is being assigned to different variables. So you have to, when you do the merge, you have to do the merge based on the on the variable and not only the collection. So yeah, it's pretty difficult. Right now the implementation only works for that type array collection, because we have to know that from the VM point of view, that you have to work that way when collecting types. So yeah, it's not that simple. It's an idea. It's working. It's good for a thesis. I'm not sure if we are going to put it in production yet. And there are other ideas also about that. But if you want more details, I can send you the.
Yeah. Send me the thesis, or we can
it is in Spanish.
Oh well, then don't send me the thesis. But then you'll have to explain it to me.
Okay, I'm glad to do it.
Or you can make the students do it. It would be good for them.
Yeah, of course. I want them to be here, but they couldn't. But anyway, yeah, for sure.
Thanks.
Well, another question? Yoshiki?
Sorry. Just curious what you say. How do you compare your work with the Lex Spoon's type inferencer he did?
I didn't compare it. I don't know how that works. Yeah, sorry.
Dave Lewis?
Yes, the type collection right now is being done on a stacked VM. What happens if you run it on a COG VM? Does it still work?
Yes, it works, but it doesn't collect the types.
Oh.
Yes. Yeah, that's
Okay.
that's yeah. So you will have all the tools, and you will have all the type information that you had when you saved the image using the stack VM with the LiveTyping, VM.
I thought that it might collect some type information until the VM warms up, but no.
No, sadly, that's something I really want to have, but I didn't have time to look at the implementation of the GPN. I know it's very difficult. There was a guy writing his thesis about that, but he left Argentina, he flew to Germany, he's living in Germany now, and he has his head in other problems. So I'm not sure when we're going to have it done. But yeah, I love to have it in the GPM, because the speed difference between the stack VM and the GPM is big.
Well, the JIT might be fast enough to do it without VM modifications. You can just collect the types whenever, like if you just recompile the system to store type information.
Well, but the thing is that when a method is, JIT and converted to machine code, you have to collect the types there, and I think that code that is in JIT doesn't use the normal implementation of the assignment and other things. That's the problem.
I mean, that's just a bytecode. So if you change the compiler that for every instance variable store, it puts the type information into that array, then it will just do it all the time.
Yeah, but what I did doesn't change the compiler. It only
I know.
works
It
on the-
would be an alternative implementation.
Okay.
Instead of doing it in the VM, do it in the image and hope that the JIT is fast enough to
that's
make
a
it
good
work.
idea. Yeah, that may work. Yeah, why not?
As long
I
as
think
it's
it's interesting.
As long as it's throwing ideas, what about doing some kind of VM upcall on a pick cache miss?
Well, that's another thing because, of course, we all know Ungar's work about pigs, and he mentioned also, using pigs to get type information. But the problem with pigs is that they are not always there. Is the pigs? There's a limit on the number of pigs that you can have, and so on. But yeah, it's almost the same type of information because. It's also a cache, what I did. The difference is that pigs are cached per message sent. And I have cache per variable. So I have more information than the pig.
So you
Right. What I'm saying is on the common case, when you have a pick cache hit, it just runs. But on the uncommon case, you do some kind of upcall from the VM, sort of like does not understand, or some message that the VM just sends. You can handle in the image. Slow, of course, but it gets the new selector, or at least possibly new selector.
So,
yeah, I think it's not possible when you have a cache miss in the pig to call, a method in the image, because you are in this, in the VM looking for the implementation of a message. But it's not the same thing. It's a very similar idea, pigs and what I did. What I have, one more thing. What I have as an idea is to change the compiler to generate the pigs and, remove that burden from the VM. So now that we have type information, why don't we use it when we compile the code instead of making the VM to generate the pigs and those kind of things? But when I mentioned that to the VM guys, they didn't like that much the idea. I don't know why. So it's an idea, and we have to see.
I can tell you why. It's because it's work for them. But that's so. Can I assume that currently you just literally scan that array to determine if something's already present, and then you guard it with some sort of similar to a pick last class added or something to make the scan missed, or you just go brute force?
Brute force. I just scan it. But it's very small,
sure.
10 elements, and I didn't show you that, but let me show you that. It's very simple. If we look at the
while you're doing
how
that,
many how the cache is being used, you will see that it's not really that much. It's very tight number. Let's see. Let me look for it. For example, here, we can see that there are 457 instance variables that have no types, will never been assigned, 1,212 that have one type, 402 types, 68 three types, and so on. So this is, the types condensed by instance variable. But if we look to the real row type, which is the interesting part, we will see that the same thing, that it goes really, really down to almost nothing. So, it's not that many times that you have to look for a space in that array, really. Not that bad. And I don't store the last time that I did it, or which one was the last class, and those kind of things, because that will make it more difficult on the VM side, and I don't see the value of doing it. At least for what I'm doing on the image side. Yeah, I don't know if.
Very cool. Thank you, Hernan. We're 90 minutes into our session. I will have to leave. Thank you all. But Craig volunteered to stay on for another half an hour, and I don't know how tired you are, Hernan, if you want to answer more questions. So everybody can feel free to leave now, but you can also stay on if you have more questions. So
thank you all for coming.
Yeah,
thank you.
That was fun.
Thank you, Vanessa. Bye.
And see you in 4 weeks.
Yeah.
See you at
one of these.
Second Wednesday in April.
Yeah. Bye.
See you. Bye.
See you, Vanessa.
So Dan, you have been quiet. Why is that? Do you like it? You don't like it? What do you think? Your voice here is very important. I don't want to push you, but
I love it, and you know that I got into type inference and various things like that way early on with Helen Borning. One thing that I thought about is there's a place where you do rollover to show the types of various variables when you're looking at a method, and I almost think that that's a mode to use, because I find it handy if I'm browsing through a bunch of methods to see that information right away without having to sort of go query for it. I noticed that you do that in one of your menu rollover features, and it feels very good there. So that's just a thought. The other thing is, every once in a while, I have a piece of code that I want to actually print out and sit outside and read, and it's nice to have it there too. So that's something.
Yeah, I agree. Sometimes you want to see it in the source code. Yeah.
And a selling aspect for things like this is the testing aspect. So I once did a program that measured how many executions there were of many functions in a big system, and and I thought that would be useful for people to do optimization, because they find out, all the time was spent in these 5 procedures. It turned out that almost the most valuable one for several customers was knowing what never got called. And so it can be useful to know that, something never, in your case, I guess it would be this thing never gets used with floating point values or something like that.
Yeah, and you can also know if a method has never been executed, because you won't have type information. So it's very easy, to know that. And also, it's very interesting, about Neil. I said that, but when you start to see, when you can be sure that Neil was assigned to a variable, then you don't have to guess anymore. Is this variable going to be Neil or not? So you start knowing much more about how the system behaves and how it's written. It helps a lot. And the same thing with true and false, because you have the class true and the class false. So, sometimes in a method you just return true. So the return type for that method is not going to be Boolean, but it's going to be true, class true. So it's more located information that gives you more confidence on the types.
No, I think it's great that you stuck with us and carried it through to the actual value to the developer. It's great.
From my point of view, I've been using this for almost 2 years, and it's amazing how students that don't know Smalltalk, how having this type information, the auto completion and the refactorings with actual scope, it's completely different than before. Before you were always hearing them complain about the auto completion is not good enough, right? And now it's exactly what the messages they can send. The refactorings work with the actual scope, so no more complaints about that. and that's great. That's great.
Yep, that's great.
Hey, Hernán.
Yes.
Can you speak a little bit on your learnings about both performance in trying to track all that information, as well as sort of how you tried to keep the memory consumption under control? Because that's always been with these kind of caches one of my challenges.
Yes. Well, I haven't done too much about performance. I just checked how much it takes, to run the image with this VM. And as I showed, it's almost 40% slower. And about the memory consumption, to tell you the truth, I didn't tweak the size of the arrays because it's so small. The quiz image. The quiz image is like 9 or 10 megs, and the quiz image with LiveTyping is 20 megs. It's nothing. So I didn't spend time reducing the size of those arrays, but most of them are with nil. Most of them have no information, so it could be reduced by a factor of, for sure, a lot of. I'm not sure how many megs you could save reducing these types of array, but for sure you could save a lot.
And those plots aren't bad for the value that it provides, not at all.
No.
I'd point out that most of the images that you use for development, they have lots and lots of classes, not so many instances. And when you run an application, you're going to have many, many more instances, and then the overhead will be proportionally smaller than
that's a good point. Production is not going to grow because of the type information, but because of the objects that you have. And again, you don't have to put in production an image with type information. If you're not using that on production, that you shouldn't do it, then it's not going to make any difference. Yeah, that's a good point. Yeah.
Just for mental comparison, just switching from a 32-bit to a 64-bit image causes quite a bit of memory wastage, even before you do anything else. So I mean, that's one of the reasons why actually I find I run a lot of 32-bit stuff just because I could save so much memory. But anyway, I think you shouldn't worry about that kind of issue until you actually see what the problems are, because my experience is it depends a lot on what kind of application it is you have as to what the challenges will be, not just whether it's production or not production.
Yeah, I agree. And to tell you the truth, I didn't spend, all what I showed. It didn't took me more than 2 months of work. So it's not. I would love to spend more time and make it better and nicer, but that's what's cool about Smalltalk. It's so easy to do stuff and so fast.
You mentioned you've been doing it about 3 years. Can you kind of speak, because at least when I do these kind of problems, and I seem to always have to run into various ones, something I never planned for emerges, and it's always this insider discovery. What do you feel were like your most important emergent insights over the 3 years of having it, building it? What surprised you?
Yeah. Okay. So one thing, I'm not using this on real production systems because sadly I'm not writing Smalltalk code for customers. I'm only using it at the university, so I cannot talk about how it, I cannot talk about how it influences on real software development. And it's been there for 2 years, not 3 years. So what can I tell you is about the examples I do when I teach, small katas like, the tic-tac-toe, the game of life, or Roman numbers and those kind of things. And what I see is, again, the tools give you that much information that allows you to work in a better way. So my projection to real systems is the same. You have more information. It's better for everybody. So yeah, but sadly, I'm not writing any production code in this Smalltalk right now.
Have you done any looking at the analytics or analytics on the kind of data you're getting? So trying to categorize programs as megamorphic or not, or whether like a beginner Smalltalker writes something that's very few types, but the hardcore Smalltalker is going to have a hierarchy from hell. No offense to the hardcore of you, but you know what I mean. Like they really do push it. A class for every single kind of variant of the data they're they're modeling or whatever. Those kinds of extremes. Have you seen anything like that you can get from this data, or thought about that, or
no,
have a
to
put on it, because that would be.
No, I haven't, but I have all the work of my students for the last 3-4 years, and I also have how they work, because we save the changes file, and I added a tool to this that is called TDD Guru, because we teach TDD and we want them to use TDD. So I have a lot of data to analyze about how students do TDD, and I could use those files, also those solutions, to see what you said and to analyze that. But yeah, I don't have time to do it. But yeah, that would be interesting. Yeah,
you have really nice data, and the fact that you can just get it in real time as part of the tool for your own value is kind of neat. But you trying to leverage it to see how people are learning Smalltalk, and whether their understanding of objects and type systems and how they refactor their code changes sort of maybe fundamental characteristics.
Yes, I agree.
The other thing I was going to mention is, once you have type information, there's a project that I think it's archived now, but it's at Eclipse. It's a Java project, of course, and it's called Code Recommenders. And what they did is they did a statistical analysis of open source projects that use Java code, and then when you do code assist, they weren't telling you, they were telling you what you could complete with based on the context that you were using it. So if you had 2 or 3 lines of creating a window system above where you're code assisting, they knew what the most likely thing you should be typing there, because everyone else typed the same thing. So there's patterns like creating a widget and then setting the font and setting the color and setting the thing, and then you do something. And all of those blocks are very common. And so once you start typing the first few characters of that thing, they know that you're in for the ride, because these patterns are fairly well defined the way to use it. Maybe the API is wrong, but that's how you use it. You cascade a bunch of stuff. Anyways, sorry. I don't want to sign up as a PhD student with you, but it'd be so fun if I was 40 years younger and willing to go there, I guess.
That would be great to do. Yeah, there are a lot of things that you start thinking about improving the tools. As I said, when you have all this information, it's new ideas all the time. For example, something I want to implement is when you remove a method. If you remove a method and it doesn't have actual senders, then you can remove. You can do a closure, and you can remove all that, and that would be great, because right now you have to do it by hand. So it would be great to.
Yeah, I mentioned at the beginning that I was using a tool called Packager to create these very small images, and we do guesswork, guess type inferencing to get this image small, because you cannot know for sure. So you have to be fairly conservative. And then there are rules that allow you to exclude it. So a system like yours would help you make even smaller images, because otherwise you have to be a little bit conservative when you keep methods.
Yes, and I think the potential for this is really, really big, and I hope that some commercial Smalltalk will take the idea and use it. I'm not sure, but that would be great. I'm more open to help on, for everybody to use it and help that, to do that. Yeah.
In the self group, the self 1 VM was created by Craig Chambers, and he used type inference. And then self 3, Urs Hosel, created the type feedback with the PICs. And then Ole Agson actually did type inference in the image level, not the VM level, the image level. And his goal was to extract. So you'd give a starting method, and it extract only the part of the image that was required to run that method. And he applied it to the sieve benchmark, like we have in Tiny. And then he was shocked to get a bunch of code that he didn't expect, like the whole floating point library, practically. And he found out that there was a chance that you could print an error message. And in the error message, it ended up indirectly using floating point. I mean, it would never happen in practice. A human looking at that would see, oh, there's no way that floating point will ever be invoked by sieve. But, like you were trying to separate the false senders from the actual senders. Well, this couldn't do that, so it brought in everything that.
It was called the transporter, wasn't it?
No, that was David Unger's work, which is sort of related, where he tried because the first few versions of Self were textual, so you typed it in a VI or some text editor.
Okay.
And only the version 4 was graphical. So now you had the problem that you were creating these objects in this graphical way, and he couldn't recreate the text that the previous version
had.
So you had to have some kind of type, but this case it was type annotation.
Okay.
So you have an object, for example, and it has an instance variable, and the value is 3. But that's not what you want to save. You want to save a code that when you run it again, well, it might be 3 or it might be 10. I don't know. It's some expression. So the transporter by David Unger was annotating stuff, not necessarily type, but you had to add a lot of information. Otherwise, it couldn't spit out the text files. Now, Ole Agson did this. His paper is called Extracting the Gold, or Sifting for the Gold. I don't remember. I can find out. But basically, he did at the image level all this type inference, and then he tried to create an image that had only what you needed. And it was the image was like 5 kilobytes long or something like that. It was really tiny image that he generated. But he always got lots of things that he didn't expect.
So what I again all the tools that we are used to see in statically typed languages, you can use it now with a Smalltalk with lively type. It's the same thing because now you have all the type information. So things like that, things like profiling, things like better refactorings, as I showed, and those kind of things. The same things can be used now because you have all the type information. So it's a very interesting topic. It opens a lot of things to do.
I'd mentioned that David Unger actually classified types among 3 different axes. So he said you can have, for example, strong typing or weak typing. So that's how easy it is to get around the type system. So C is a very weakly typed language, not a strongly typed language.
That's so
Smalltalk is a strongly typed language, for example. Although you have Become, which gets around the strong. But and then the other axis was statically or dynamically typed, whether it's the variables or the instances that are typed. And his other axis was abstract versus concrete type. So, for example, if you have unsigned integer 16, unsigned integer 32, that's concrete types. So it's what's the bits in memory. That's what concrete type. Whereas abstract types is what message you can send to it.
Yeah.
As long as we're talking about three-dimensional classification of type systems, I would feel remiss if I didn't mention the Barendrecht cube.
What cube? Sorry.
Barendrecht cube. It's a classification of type systems. It has to do with various ways of classifying actual, statically typed systems. For instance, if you have a type that depends on data, then you can do matrix multiplication, where the horizontal dimension of one matrix has to be the vertical dimension of another. And that's a type that actually depends on a data value. Your standard type systems only involve types to types. And, the ultimate corner is like a dependent type system where you basically have a full Turing complete calculation upon types and provable correctness. But, that's the whole insane theory stuff that's impossible to use, which is why I love Smalltalk, where it's just fun to get shit done because it's a live system I love living in.
I didn't know that cube that you mentioned. What's the name again?
Barendrecht. I look at Wikipedia because there's no way I'll fucking spell that from memory.
Okay.
Oh, God.
Not there?